This form of the Ohm's law equation allows you to calculate current when voltage and resistance are known. You can also rearrange the components in Ohm's law to solve for voltage, which is current multiplied by resistance, and for resistance, calculated when you divide voltage by the current flow of a circuit. A tool to assist in calculating the values associated with the Ohm's law equations is the Ohm's law circle. If you want to solve for voltage, then you multiply current and resistance. If you want to solve for resistance, then you divide voltage by the current. If you want to solve for current, then you divide voltage by the resistance. Let's look at a few circuit examples and use the various formulas to calculate the values of each of the circuit components. So, for the following circuit, if a light bulb in a lamp has a resistance of 105 ohms, and the voltage to light the lamp requires 120 volts, how much current flows through the light bulb? Using the Ohm's law circle and solving for current, you would divide the voltage by the resistance. So 120 volts divided by 105 ohms is 1.142 amps. So you have 1.142 amps of current flowing through the light bulb. Using the Ohm's law circle, if you know the values of any two variables, you can solve for the third. If you have a current of 2 amps and a light bulb with a resistance of 4.5 ohms, the voltage would be 2 times 4.5, or 9 volts. If you know the voltage in a circuit is 200 volts and the amps is 0.25, then 200 volts divided by 0.25 is 400 ohms. Here we have a typical circuit found in a flashlight, a light bulb, a switch, and a battery. Using a digital multimeter, let's measure the voltage across the battery. Set the DCV on the multimeter to 20 volts. The battery used in this circuit is a 1.5 volt battery, so the 20 volt setting is within the range of what we can expect the voltage reading to be. After visually inspecting the terminals of the battery to determine the polarity of the battery, place the red probe across the wire on the positive side of the battery and the black probe across the negative side. You should get a reading of around 1.5 volts. The voltage of the battery is 1.57 volts, and about what we would expect. Now let's measure the voltage across the light bulb. As expected, with current flowing, it too is 1.57 volts. Now, if we put the switch in the off or closed position, we will still see the voltage across the battery. However, the voltage across the bulb will be 0. This is expected, as the light bulb, which is the load in this circuit, only has a voltage across it if a current is present. Now let's determine the resistance of the bulb in the circuit using the Ohm's equations. If the current in the circuit is 0.3 amps, and the voltage across the battery is 1.57, then the resistance of the light bulb would be 1.57 divided by 0.3, or 5.23 ohms. Let's check the actual resistance of the light bulb using the meter. Make sure the switch of the circuit is open or in the off position so no external power is in the circuit. Look for the ohm symbol, which is the Greek letter omega, and switch the meter to 200. Now place the leads on either side of the light bulb. You should see a reading of 5.23 ohms.